In this video, I'm going to go over the electric rail bike build. There were a lot of questions about the bike, the railroad attachment, and a few other aspects of the video. First I'll go over the frame, then we'll go over the battery and the rail attachment. After that, I'll go over the filming and a few other questions about the video. I'll put timestamps in the description if you want to skip to a certain part. This is a quick time lapse showing how I built the frame. This bike was originally designed to be a delivery/cargo bike and also as a long-range commute bike. So some people have asked why I chose a rear hub motor and dual rear shocks instead of a mid-drive. It's true that mid-drive motors are better for off-road and performance. However, I wasn't looking to create something high-performing or specifically for off-road. This was designed to be a cargo commute bike. The main disadvantage of a hub motor is it increases the unsprung weight, which has a negative impact on your suspension. You can see here how the back end of the bike bounces over these bumps. It's kind of like riding a mechanical bull. The advantage of using a direct drive hub motor is that they're dead silent. They have no drivetrain or any other moving parts, except for the wheel itself. But the main reason I went with the hub motor and dual rear shocks was to get the motor and shocks out of the battery area so I could fit in as big as battery as possible. The motor I'm running in this bike is a QS205 hub motor. This motor is rated at 3 kilowatts, but it will handle 10 kilowatts quite easily. The controller I'm using is a Kelly KLS 7230S, which has a 120 amp continuous 300 amp max rating. When I'm going all out with full throttle and in the high range, the digital meter is registering a power output of approximately 9.5 kilowatts. I got quite a few questions in the comments about the legality of this bike, so I'll explain how it works here in California. This is a motorized bike plate, which is what I run on my high-powered e-bikes and my gas-powered bikes. It looks just like a motorcycle plate, except there's no expiration tags. Without this license, and if it's electric, you're limited to 20 miles per hour. If the bike is electric and pedal assist, then it can go 28 miles per hour. With this motorized bike plate, you can go 30 miles per hour, and you don't have to have pedals if it's electric. If it's gas-powered, then you do have to have pedals. If I'm not running a license plate on this bike, I have 3 different power levels on my controller that I can set at 20 miles per hour or 28 miles per hour with pedaling if I want to be legal without a license. The battery is made up of 2 packs of Samsung 50E 2170 cells, 20 in series and 7 parallel, making each pack 72 volt, 35 amp hour, or 2.5 kilowatt hour. That way, I can run a single pack or a double pack in parallel to give me a total of 72 volt, 70 amp hour, or 5 kilowatt hour. I usually just run 1 pack in the box like you see here because it's 24 pounds lighter if I don't need the extra range. This single pack gets me around most places. The full battery with the double pack weighs about 50 pounds, and with 1 pack, it's about 25. I had the packs made by a Chinese company called Buant that makes custom battery packs in whatever size you want. They claim to be using genuine Samsung, Panasonic, and LG cells. I purchased a pack similar to this one on their website, but I had it custom made to fit my battery pack's specific size and specifications. As for the range of the battery, I tested it on a level road with no stops and starts at 20 miles per hour and got 200 miles out of the full pack. Riding the bike at normal speeds, 25 to 30 miles per hour with stops and starts, like regular city riding, I'm getting around 100 to 120 miles with the full pack and about 50 to 60 miles with the half pack. I was testing this bike to see if an e-bike could be used as a long-range commute vehicle. A typical commute in this area is going from Santa Cruz to Apple Park in Cupertino. This is about a 36-mile ride going over a mountain range with a 1,700-foot elevation. Google Maps claims this is almost a 4-hour bike ride. By car, this is around 50 minutes, but in traffic, it's more like an hour and a quarter to an hour and a half. Licensing this bike with the motorized bike plate, I made this trip in about an hour and 10 minutes at the legal 30 miles per hour. One thing about this plate is that the 30-mile-per-hour speed is measured on level ground. Therefore, if you are going downhill, you can go faster than that. So I'm able to do about 40 miles an hour down the backside of the mountains. With the full pack, I could make this trip there and back on one charge. With the half pack, you would have to charge the bike up at Apple before you could return home. This is another version of the same bike I just made for a customer that has a smaller battery pack. I shortened up the battery box area so it's not quite so big. I went with a 72-volt, 45-amp-hour pack in this bike that I also got from Buoyant, except this one is one of their metal-encased batteries instead of their shrink-wrapped batteries. This 3¼ kilowatt-hour battery weighs in at about 34 pounds. Currently, I'm working on building another one of these bikes. With this one, I'm going to use a standard e-bike battery and a 750-watt hub motor, so it will be lighter and legal to ride without a license. The swing arm has bolt-on dropouts, so I can basically put whatever hub motor I want in the bike, and I'm also thinking about having the option for a bench seat. It's a little more comfortable and could take an additional passenger. I'm considering the possibility of producing and selling some of these bikes. To meet legal requirements, the bike is likely to be equipped with a 750-watt motor. However, the frame would be designed to be compatible with the larger battery pack and motor for future upgrades. So I'll try to go over some of the questions I got regarding the rail attachment. One of the questions I got was how the front rail attachment is mounted to the forks. It basically just clamps onto the fork legs with these split clamps. Another question I was asked was what the front roller is made from. The front roller discs I made out of a sheet of 3/8-inch ABS plastic. The front roller itself is a 110mm rubber longboard wheel. This is what the longboard wheel looks like by itself. These rollers here are inline skate wheels. The inside one is fixed and the outside one is spring-loaded to be able to go over the grounding straps. This is my test track that I made out of 2x4s that I used to test my rollers on. This aluminum piece screwed on the side here simulates the grounding straps. This is how the front wheel folding mechanism works with the over-center mechanism. Another question I got asked a lot was what keeps it from tipping over to the right, and the answer to that is a slight lean to the left, which is done with this adjustment here. The outrigger wheel can be raised or lowered to give you a couple degree tilt to the left. Some people asked what these bent tubes are for in front of the roller. Most people thought they were to clear brush and sticks out of the way. While they do help a little clearing brush and sticks, their main function is actually to prevent the front roller assembly from getting caught on railroad ties and joints in the event of a bike derailment. When I first made this rail attachment and was testing it on my pedal bike, I hit something that caused it to derail. When it derailed, this front axle mount caught on one of these rail joint bolts like this, and when it did, it instantly stopped me and sent me over the bars. So after that, I put on these curved rods I call ski tips. These rods are angled outwards so that if I derail, these tips will hit on the top of the rail and keep the roller axle away from the track joint bolts. The other thing they do is help the roller assembly skate over the tops of the railroad ties. This is why I use 7-inch diameter discs on the front wheel. So if you're riding abandoned tracks with a lot of vegetation and debris, you need to think about what's going to happen if you come off, because eventually you probably are. I think the safest way to make a rail attachment is to use 4 wheels and locate on the inside of the tracks just like a train. The only reason I'm doing it like this is because I was trying to do it with the bare minimum amount of attachment as possible to be able to fold it up onto the bike and ride it as normal. So now I'll go over some of the filming questions. One question that often comes up is how the drone shots were captured on the beach cliffs, so I'll go over the process of how I got those shots. The drone I'm using is the DJI Mini 3 Pro. It basically has 4 follow modes: spotlight, point of interest, trace, and parallel. For this shot here, I used what's called the point of interest shot, in which you pick a point on the screen and the drone flies a circle around that point. So I picked this point on the bluff as the point of interest, and the drone starts flying in a circle around this point. I then rode out to the end of the bluff, turned around and rode back, while the drone was circling around the point. For this footage, which I think is the best footage of the video, I used what's called the parallel flight mode. This is where the drone follows you flying sideways. The one weakness of the Mini 3 Pro is that it has no sideways sensors, so it can run into something when it's flying sideways. But up here on these cliffs there are no trees or buildings, so I'm able to use the parallel flight mode without worrying about running into something. With the parallel flight mode, you get a lot more dynamic scenes. You can slow down, and the drone will swing around in front of you while flying backwards, and then you can speed up, and the drone will swing around behind you. In trace mode, the drone just follows directly behind you. In this mode, the drone does have collision detection and can avoid tree branches, but it can't fly sideways and move from front to rear like in parallel mode. I think I got almost as many questions and comments about the narration as I did the bike. Some people liked it, and some people hated it. I was trying to go for the narration sound of a Bruce Brown or Warren Miller style action sports film, like On Any Sunday and Endless Summer. I always liked watching these types of films as a kid. So I decided to try ElevenLabs Voice AI to give it a professional sounding voiceover. And I think that the sound of their voices are nearly perfect, but what is off is the tone of the voice. ElevenLabs does not have any tone control, and that's what most people complained about, was that it sounded overly dramatic and serious. Once ElevenLabs incorporates some form of tone control into their technology, I think it will be virtually indistinguishable from a human voice.